Hi everyone, and welcome to my channel. Ever wondered how some of the most advanced military machines can fly right through enemy territory completely undetected? It's like something out of a science fiction movie, right? But it's real, and it's called stealth technology. Today, we're going to pull back the curtain and explore the incredible science that makes aircraft, ships, and even tanks virtually invisible. It's not a single magic trick, but a combination of brilliant engineering and materials science. So, buckle up as we dive into the shadowy world of stealth. First up, let's talk about the most iconic feature of any stealth aircraft, its shape. Think of planes like the F-22 Raptor or the B-2 Spirit bomber. They look incredibly futuristic, and that's for a reason. Traditional aircraft have rounded bodies and vertical tails, which are great for aerodynamics, but are also perfect reflectors for radar signals. A radar system works by sending out radio waves and listening for the echoes that bounce back. A conventional plane is like a mirror, reflecting those waves straight back to the radar receiver, shouting, "Here I am." Stealth aircraft, on the other hand, are designed with flat surfaces and sharp, angled edges. This is a core principle of stealth called shaping. These angles are precisely calculated to scatter incoming radar waves away from the source, much like how a disco ball scatters light in all directions. Instead of a strong, clear echo returning to the radar dish, the signal is deflected in thousands of different directions, making the aircraft's radar signature incredibly faint. It's not truly invisible, but its signature might be as small as a bird's or even a bee's, making it extremely difficult for radar operators to spot and track. The same principle applies to stealth ships, which use angled superstructures to deflect radar waves across the ocean surface. But shaping alone isn't enough. The next layer of invisibility comes from special materials known as radar-absorbing materials, or RAM. These are not your everyday paints or coatings. RAM is a composite material, often a closely guarded secret, designed to literally soak up radar energy. When radar waves hit a surface coated in RAM, instead of bouncing off, their energy is converted into a tiny amount of heat. It's like throwing a tennis ball at a thick foam mat instead of a brick wall. The ball just drops instead of bouncing back. These materials are often made of ferrite particles suspended in a polymer matrix or carbon-based substances that are highly effective at absorbing electromagnetic energy across a wide range of radar frequencies. This paint is applied in layers over the entire surface of the aircraft, especially on leading edges, intakes, and other areas that are likely to reflect radar waves. This combination of shaping and RAM is a one-two punch that drastically reduces what's known as the aircraft radar cross-section, or RCS. For tanks and other ground vehicles, RAM can help them blend into the background clutter on a radar screen, making them much harder to target. Now let's talk about heat. Radars aren't the only way to detect a vehicle. Modern sensors can pick up on infrared radiation, which is just a fancy term for heat. And what's one of the hottest parts of any jet? The engine exhaust. A huge plume of superheated gas is like a giant "follow me" sign for heat-seeking missiles. So, how do stealth designers deal with this? It's all about clever engine placement and exhaust management. On many stealth aircraft, the engines are buried deep within the fuselage. This shields the hot turbine blades from being seen by sensors below. But what about the exhaust? On aircraft like the B-2 Spirit, the hot exhaust is channeled through long, S-shaped ducts. These ducts are lined with heat-absorbing materials. Before the exhaust even leaves the aircraft, it's mixed with cool bypass air from the engine. This significantly lowers its temperature. The exhaust nozzles themselves are often flattened and angled upwards, allowing the plume to mix with the cold air at high altitude even faster, dissipating the heat signature and making it much harder for infrared sensors to lock on. Stealth ships use similar techniques. They might vent their hot exhaust gases near the waterline, using the sea spray to cool the plume, or mix it with cool air before releasing it, just like aircraft. Every little bit helps to reduce the thermal signature and stay hidden. But the quest for invisibility doesn't stop there. Stealth technology is a holistic approach that considers every possible way an aircraft could be detected. What about the noise? Stealth aircraft are designed to be quieter than their conventional counterparts. What about its own electronic emissions? Stealth aircraft use advanced avionics that can perform their missions with minimal use of active radar or radio communications, which could give away their position. This is called low probability of intercept or LPI. Their own radars use complex, rapidly changing frequencies that are difficult for an enemy to detect, almost like whispering in a crowded room. Even the pilot's cockpit canopy is part of the stealth package. A standard canopy could allow radar waves to enter the cockpit and bounce off all the equipment inside, creating a huge reflection. To prevent this, stealth canopies are often coated with a very thin, transparent layer of gold or another conductive material. This layer is just thick enough to reflect radar waves away while still allowing the pilot to see clearly. It effectively seals the cockpit, turning it into another part of the aircraft's stealthy, radar-scattering surface. And this technology is constantly evolving. Researchers are developing new metamaterials that can bend light and other electromagnetic waves in ways that were once thought impossible, potentially leading to a new generation of even stealthier vehicles. We're also seeing the application of these principles on a smaller scale with stealthy missiles and drones that can penetrate deep into defended airspace without being noticed until it's too late. Tanks are being designed with thermal cloaking tiles that can change temperature to match their surroundings, making them invisible to thermal cameras. So, from its distinct, angular shape and radar-absorbing skin to its cooled exhausts and shielded electronics, stealth technology is a masterclass in physics and engineering. It's not about being truly invisible, but about reducing a vehicle's signature across the entire electromagnetic spectrum to a point where it can operate undetected, giving it a decisive advantage. It's an intricate dance of deflecting, absorbing, and cooling that makes these machines some of the most sophisticated ever built. Thanks so much for watching. I hope you found this deep dive into the world of stealth technology as fascinating as I do. If you enjoyed this video and want to learn more about incredible feats of engineering and science, be sure to hit that like button and subscribe to the channel.